That's good. Oh, okay. Before we move forward, I'm gonna go through this percentile section of this. There's another thing that got mentioned in the lecture is this idea of percentiles. Now, you guys know percentiles from exams, right? For instance, when you take the SATs or the GREs, you not only got a score, like when most people here got what, 800s, 900s on each exam, so you got a total like 2,000 or something, right? We all got high numbers, right? So that would put you in the top 2%. Well, that would put you in the bottom, a low score might put you in the bottom 40% or something like that. So percentile represents how many, where a particular value is. What number, for instance, what score that has 40% of the people below that value? What score has 75% of the people above that value? So the 75th percentile, 75% of the people are below that score, 25% of the people are above that score. Well, a couple of the number percentiles that we're most interested in are the 25th percentile and the 75th percentile. Anybody remember why we're interested in those two particular percentiles? What do they use to calculate? The interquartile range, right? The interquartile range is the middle 50%. Okay, think about quartiles. What are quartiles? The lowest 25% of the people, the second 25% of the people, the third 25% of the people, and the highest 25% of the people. The interquartile range is the middle two quartiles, the 25th percentile to the 75th percentile. Why is that of particular interest to us? Well, the nature, you notice that these normal distributions, there's a lot of people in the middle, not so many people on the outsides, right? So these values tend to bunch up in the middle. They tend to have a central tendency, right? So the interquartile range, that range where 50% of the people are, well, that's of importance to us because we know that close to those numbers is going to be most of that population. So we're very often interested in that range. So we're going to calculate this for this particular sample. So in this case, you could almost say to yourself, well, I know that these are the lower half of the people, and these are the higher half of the people. So this is the bottom 50%. This is the top 50%. So you can almost say to yourself, well, I'll just look at the bottom 50%, and the middle value there is 94. Maybe that's kind of the 25th percentile. 25% of the people are below that, 25% of the people are above that. Similarly with the value 104, in this case there's a lot of 104s, right? 25%, that's the middle of the upper half of the people. So it's kind of like, I think that they're going to be somewhere around those numbers. Well, we're going to actually, very frequently we're not going to be dealing with a sample size 18. We might be dealing with a sample of, in fact, we have one that we're going to work with, hopefully, if we get to it today, that has a sample size of 800, for instance. It's going to be a lot more difficult to do something like this, so we actually want to calculate it. So I'm going to click in here to 75th percentile. I'm going to type in equals percentile, parentheses. I'm going to ignore all those other versions of it, parentheses. And it asks me to tell it the array and K. Array just means basically a range of numbers or a list of numbers. So what's the array? The array is all of these numbers that I'm dealing with, all of these individual values for each subject. Comma, then it wants a comma, and there's a value K. That value K is the percentile we're interested in. But we want to put it in as a decimal place. So I'm going to put it in as 0.75, 75th percentile. Okay, I'm going to hit enter. And bingo, 104. That's the number we were actually looking at a second ago, right? So let's do it for the 25th percentile. I'm going to do the same thing. I'm going to click in here, equals, percentile, parentheses. And now I'm going to, again, it wants to know the array and the value K. If you went into that function, the little f of x, that little function list, and put this in, it would tell you that K represents a decimal expression which represents the percentile. So the array is A2 through A19, comma, the percentile this time is going to be, 25th percentile, it's going to be 0.25. 0.25, yeah, for 25th percentile, you would put 0.25. Okay, so 94.5. In fact, it was between 5 and 6, I guess it was, or something like that. So you could do this for any value, for 10th percentile, for the 90th percentile. You do for any, but of special interest to us is the 25th and the 75th, because I can say, okay, 104 minus, this is equal to 104 minus 95.4, well, 9.5, a value of 9.5, like blood pressure, like millimeters of mercury, whatever it is, right, is what separates the 25th percentile from the 75th percentile in this population, represents the interquartile range in this sample or by inference population. Okay, so we've learned a lot of new values here. Some of them, percentiles, interquartile range, minimum, maximum range, standard deviation, variance, they represent how spread out the sample is. Some of them, mean, median, and mode, represent where the middle of the sample or the population is. Okay, so now you get a chance. I understand that some of you guys are picking this up very quickly, and others of you don't have as much experience with Excel, so you're a little bit of a disadvantage. So I'm trying to make sure we keep up for the most part, but I know we're not all going to get this at the same rate. There'll be other things that you guys may be better at later on. So I don't want to bog down on too much of this stuff, but you can always go back. This is going to be posted online. You can always go back and rewatch this. And we can always repeat it. We'll have others as we go on in the semester. You'll have a Thursday session where, a tutorial session where you can go online, ask questions and so on and so forth with Professor Rendina. I'm not sure if it's every Thursday. I don't know what the exact dates were. We're still working out the exact times and dates. But this will still be available to you, right? And I may be doing, as we get closer to the exams, I may do some review sessions also, okay, that either here or online or something like that. Okay, so let's go to the next file. Okay, yes, number 2, descriptive statistics, so on and so forth, histogram. Okay, so now I'm going to sort this data. Again, I'm just going to highlight this column, and I'm going to tell it to sort it for me. I'm not going to bother to highlight the column next to it. I'm just going to ask it to go ahead and sort this for me. And again, it's hidden up here. Oh, now notice it gave me a warning. You have selected only some of the available data. Only the selected data will be, do you want to expand the selection to the rows adjoining, the columns adjoining this, right? Well, they're empty, so I don't need to do that, right? But were they not empty, I would have left it and said expand the selection. But since they're empty, I'm just going to say continue and just sort this column. Okay, and it's sorted for me. So now there's a number of ways. I'm going to look at this. I'm going to look at the numbers that I have here, and I'm going to sort them into bins by the frequency of the range of those numbers in those bins. Okay, so now I'm going to actually cheat a little bit. I'm going to copy this off. But no, I'm not going to bother doing that. I'm going to change this to below 89. 89 and below. How about that? I'll call it that, 89 and below. Okay, so anything 89 and below is going to wind up in that bin. Now, there's a few ways I could do this. I could do this by using the COUNTIF function. Only count the values that are below 89 in this column. I could use, and the next one I could count ifs. Only count them if they're between less than 95 but more than 90, and so on and so forth. It's going to complicate things a little bit. I want to keep it simple for right now because I want us to just look at the statistics for right now. So when we deal with bins and histograms, we're about to make a histogram, we're dealing with frequencies. How often does this number within this range come up in this sample? Well, how many people do we have that are below 89 and below? 2. Okay, I'm going to put 2 in there. I'm going to make it really simple. How many? Yeah, I'm just doing it manually. 90 to 94. Okay, 3. 95 to 99. 95. Anybody? 95. Yeah, there is. There's 5. 4. Okay. 100 to 104. 5. 105 to 109. 3. 110 to 114. 1, and there's none over 115, right? Okay, I'm going to highlight these 2 columns, like so. I'm going to go over to the chart function, chart ribbon, and I'm going to ask I'm going to ask Excel to make a column chart for me. Okay, I'm sorry. Do you have to do insert on your version?
Yes.
Okay. On mine, I can just go over to charts and click on that and highlight that. You guys may have to do insert. So I'm gonna escape here. I'm gonna go. It's highlighted. I'm gonna go up to insert, chart, and what happened? How come I don't see my window open up? Insert, chart, and it's not cooperating with me. Where is it? Oh, don't know where it went. I have to use the ribbon. You can use the insert chart. I'm gonna click on charts. I'm gonna click on just clustered column, and it makes a chart for me. And the chart on the y-axis is the frequency, the number of people that fall into that bin. On the x-axis, it gives me what each range represents. Okay, now something interesting, something funny about this, right? What's funny about this? Well, there is really no gap between these bars, is there? In other words, if you weren't in this bar, you would not be in between here. You would be in the next bar. So I don't really want it to look like this. A good histogram should look like, and I'm going to double click on this, a good histogram here should have, instead of a gap width of 100%, it should have a gap width of 0%, right? Shouldn't be any gap between them. I did that by double clicking on the bar, and it brings up a window that lets me on any one of the bars. Double click on any one of the bars and a window pops up like that. Okay? So if you don't have to worry about doing that if you don't want to, right? But I removed the gap from there. Why did I remove the gap? To illustrate the fact that there are not going to be any values that are going to be missed here. You're either in one bar or another bar. So how many people have blood pressures below 100? Well, 4, 3, and 2, that's 7, 9 people, right? How many people have blood pressures 100 and over? 5, and there's 3 in here, and so on and so forth, right? You can interpret the distribution by looking at this this distribution. Where is the mean? Where is the mean, do you think? Mean somewhere in the middle here, right? Is this a bimodal or single modal? Just one mode, right? The highest value, here's the mode here between 100 and 104. And so on and so forth. Okay, this gives us a window on what this data looks like, the range, where the middle is, so on and so forth, whether it looks normally distributed. Yes?
So when you're making a graph, the first category is always going to be on the x-axis?
The categories, the grouping, the category is going to be on the x-axis, and the frequency is going to be on the y-axis. The height of the bar represents how many people, how many subjects are in that bar. Okay, so this is frequency.
Bins and counts. So if you put it the other way around, the count should go first.
You mean if I put the counts in front?
No, I mean like in the Excel, right? You have bins and count.
Yes.
If I put count first.
Let me get this out of the way so I can see.
Like it would be on the x-axis then.
Yeah, then count would be on the x-axis. You don't want that.
Yeah, I know.
Right.
So it's whichever is first is going to be on the
Yes, exactly. Yeah, Excel has no idea what these numbers are. All Excel knows is that it's prepared to see this as what's in this row. Particularly in this case, it interprets this. There's text in here, so it interprets those as labels or text. Right? On this side, there's numbers. Notice how these are centered and these are wind up, pushed to the right aligned. That's because that's what it does with numbers when you just type a number in. It right aligns it. Okay, and text, it either left aligns or centers depending on how you formatted it. Right? See that put text in, say to the left number. So it only knows the way you put the position. So you got to put it in that position. In fact, if I'm lucky, I think if I type in here, some text in here, and I redo this, highlight all of these, I think that might use that as the title, if I'm lucky. Did it? Oh, no, it took it as another, yeah, yeah.
And when I highlighted bins and count, I didn't add in blood pressure, but I highlighted bins and count.
Yeah.
Plus all that, and then it just made the title count. And it didn't say bins anymore.
Oh, okay. Yeah, kind of a little bit tricky, right? there's a formatting for this. I don't want to go into too much of it, but that just goes, you can very easily use Excel to make quick charts and graphs and so on and so forth. If we were dealing with the number of, let's say instead of ranges of numbers, 90 to 94, so on and so forth, that each one of these values represented hair color. There's 4 people that have brunette hair. There's 5 people that have black hair. There's 3 people that have blonde hair. There's 1 person that's a redhead, so on and so forth. Then when we drew this column chart, we would tolerate them being separated because they're not numbers. It's not a continuous scale. That in that case, it's not a histogram. It's just a simple bar chart or column chart, if you want to call it that. Okay. Difference between a column chart is that it's or a bar chart is that it represents the frequency of a nominal variable, like hair color, right? A histogram represents the distribution in numbers within different bins, the frequency that those numbers occur within ranges or bins. Okay, everybody comfortable with that? Let's go to the last exercise. Yes.
Can you just show how you would have used count if?
Tell you what, let's do that online next time. I'll do it I'll have a session online. And in fact, wait a second. There is last Thursday on the tutorial session, he went into a rather elaborate version of how to use COUNTIF, because he had a data set that was males and females and had some other numerical data inside, and he did count. Well, just count the males, use COUNTIF to count the males and females. So if you look at that on the Thursday session, that'll help you out on that. Yes. Yes.
Just that towards the end, when he was going to the top of the spreadsheet,
yeah,
you can see it just was a little bit hard to see it. Is there any way you can expand the spreadsheet? So
I don't think we can go back and redo it, but we can redo the exercise. We can redo the exercise. Yeah, I'll try and we'll try and keep an eye on it. But yeah, it's because it's small and stuff. I blow these up so we can see it a little bit better. Okay, the third document is number 3, Descriptive Statistics, Excel to SPSS. I put that in there because it's the same data that we've been working with all along, except that it's just kind of bare. It's just like there's no titles or anything like that. It's just the numbers themselves. We're going to use that in a second. Okay, and the way we're going to use it is we're going to start by opening SPSS up. Okay, and if you go into your programs, into the start menu in the programs, you can find SPSS. The other way you can start the program is to go to the files that are on Blackboard and open up the data set. There's also a description of some exercises here. Open up the North Carolina birth data. Okay, and the one that you want to open up is the one that has the .sav postscript, where it has you may not see the postscript, but you'll see a little symbol that looks kind of like that tells you that it's an SPSS file. Okay, so you can double click that file, download it and double click it, or you can download it and then open SPSS and open it from SPSS. That's NC Birth 800 mod SPSS file. Okay, but there's a couple of versions of it. One's an Excel version, one's and so on and so forth. It's in the lab section, lab tab, session 2. Right, session 2.
Oh, it takes a little bit.
You got it. Yeah, SPSS is very slow to open.
Yeah. Nothing's happening now.
So this is the 21
It'll open.
already in SPSS?
Yeah. Okay. If you look up here, I have the file open in SPSS. I'm going to wait for you guys to manage to get it open. Okay. NC Birth 800 mod SPSS file. There's a couple of versions. Again, there's an Excel version. That'll open up in Excel. You'll know you got the wrong one there if that happens. And there's the .sav. And the .sav, you may not see the .sav because IBM likes to hide it, or Microsoft likes to hide it. You'll just see this. You'll see instead of the Excel spreadsheet symbol, you'll see a SPSS symbol. Let me see if I can't get to blow this up a little bit. right? Like on mine, you see that symbol on mine? It's an SPSS file. Okay. Okay, you guys managed to get that open for the most part?
Data view, right?
Data view. Oh, okay. I'm glad you mentioned that, right? Because there's actually several different views for SPSS. Now I have a data file open here. Just like Excel, we have a data file that has has columns, and it has rows. Except that it's not an Excel file. These individual cells are not places where you can put a formula or do calculations. They're just storing data. The columns represent the variables. For instance, sex, gender, age, mother's age. This happens to be birth data from North Carolina. Weeks is weeks of gestation. Marital status, married, not married, so on and so forth. Some numerical data, amount of weight gained. Excuse me. Okay, so plurality, I think, is the number of infants born. Like these are twins, number 205, row 205 are twins. So at any rate, each row represents a different subject, a different mother, a different birth, right? Okay, catching up? All right, so now there's 800 different births that are represented here, right? You go all the way down, you can scroll down, scroll up, and so on and so forth. The columns represent the different variables. For instance, down here we have whether or not the infant was premature, and so on and so forth, the amount of weight the mother gained, whether the mother smokes or doesn't smoke, smoked or didn't smoke during pregnancy. Now, if I click on variable view at the bottom, it switches views. And you'll notice that instead of plurality, sex, mother's age, so on and so forth being in columns, they're now in rows. This describes in detail that variable that's in the columns in the data view, right? So there's 15 rows in the variable view. So that means there's 15 columns in the data view. Okay, and if I go back into the variable view, you'll see that, for instance, gender, sex, is a nominal variable. See down at the end there, if I click on there, you can see it up there. I can choose nominal, ordinal, scalar, and so on and so forth. SPSS takes a guess based on what the data looks like. It looked at mother's age, and in fact, it got that right also. That's scalar. It's not ordinal or nominal. You have three choices. Scalar, in other words, numeric, ordinal, which it is not, and nominal. Okay, so scalar. Okay, so this describes the actual data that we're dealing with, the variable that we're dealing with. There's a section here that says label, for instance. And under label, it gives a better description than just the variable name. For instance, plurality, number of children born of this pregnancy, sex of the child, not sex of the mother. You would usually be able to guess that, right? You wouldn't need that as a variable, right? age of the mother in years. Why do we want that label besides the variable name? Because when we produce data, output data from this, tables and charts, we don't want it to say age or mage because nobody will know what that means, but it'll substitute the label for the variable name. Variable name has very strict rules. Can't have so many, it only accepts so many letters. It's always got to start with a letter. It can only have letters and numbers, can't have special characters, can't have spaces. So it's not really suitable for display, but you still need a variable name that's descriptive enough for you to figure out what to do with it. Okay, so I'm going to go back to the data view, and I'm going to look at this table that this document that I just opened up that's on Blackboard, where we're going to take a look at a couple of quick exercises that we're going to do. We open the data file in SPSS. Now we're going to do frequency. We're going to do frequency charts. We're going to do a histogram, basically. Okay? So now, the way I'm going to do this, or I'm going to do a bar chart if it's a nominal data. Use SPSS to calculate the frequencies for the number of mothers who smoke or do not smoke. Smoke or do not smoke. Is that nominal or is it numerical?
Isn't it categorical?
It's categorical. Nominal, categorical, same thing, right? It's categorical or nominal, right? So when I make a frequency chart, a bar chart that describes frequencies, is it going to be just a simple bar chart or a histogram? It's going to be a bar chart, not a histogram, right? So I'm going to go into this data, and I now have to go ahead and do this. I want it to calculate frequencies for me. So let's calculate frequencies. How will I do that? Well, I'm going to analyze the data. So I'm going to click on Analyze. I'm going to go to Descriptive Statistics, cause frequencies, means, medians, so on and so forth. Those are all descriptive statistics. And my first choice underneath there is frequencies. Click on that. Now you'll notice that all of the variables are listed here on the left. I only want to know how many mothers smoked and didn't smoke, so I don't need to work with all of these, but I have to tell SPSS which ones I want to work with. And I do that by choosing the variable I want, smoke during pregnancy, and move it into the variables box. Okay, so now I can do various statistics on this. I'm going to click on statistics. Well, we're not going to do statistics on that because means and medians for just smoked or did not smoke doesn't make any sense, right? We're not going to take a mean for that. But I do want to make a chart. Let's make a bar chart from this. And we're going to use the frequencies on the bar chart. I'm going to click Continue, and I'm going to go ahead and say OK.
What choices do we pick from?
I picked bar chart. Okay, so it selected, it calculated the frequencies. Let's see, mother did not smoke during pregnancy, 684 mothers. Mother did smoke during pregnancy, 114. And here's the bar chart that it created of that output. Okay, pretty simple, right? Saved us a lot of trouble compared to what we would have had to do for 800 rows in Excel. Yes. Okay, I'm going to go back to Analyze, Descriptive Statistics, Frequencies. Okay, I'm going to move the value smoke during pregnancy, that variable. I'm going to move that into the box on the right so the SPSS knows that that's the one I'm going to work with. If that were a numerical variable, I might want to do some statistics on it, mean, median, mode, but it's not. So I'm not going to check off any of those boxes. Little tab here, charts. Well, I checked off bar chart the last time. Let's get adventurous and check off pie chart this time. And I can either use percentages or frequencies. In frequencies, it'll give me the number next to the section of the pie chart. It's going to give me 684 and 114. If I check off percentages, it's going to give me percentages instead. It'll still be the same pie chart. So I'm going to do percentages this time instead. Right? So I'm going to click Continue. And then I'm going to say OK. Okay, and again, it calculated the same thing. Notice 684, 114. The frequencies is just a simple count, and it did it displayed these on a pie chart. Okay, and in fact, you can edit this if you want to. You can change the title and so on and so forth if you want to. But notice how it's using the labels instead of using the variable name, which might have been smoke or something like that. Okay, so let's go back and take a look at the next thing we might want to calculate. How you guys doing online? Okay, no comments so far, so I'm hoping that that's a good thing. All right, so now I'm going to go back here. What was the next thing that comes up in this exercise? Well, one of the things I asked you to do was copy and paste the result here. In fact, if you look at the exercise, the homework assignment, there are places there where they ask you to take a chart from Excel or from SPSS and to paste it into a Word document and upload that. Because it's nice that you have this in the output of SPSS, but you're not going to use that to hand in a paper, to submit an article to a magazine and so on and so forth. You want to be able to take that chart and use it somewhere else. Okay, and to do that, all you have to do, I'm going to go back to SPSS here, wherever I put it. And now keep in mind now, I have 3 windows I'm working with now. I have the data view, the variable view. I'm going to go up to window. I also have an output window. And that output window accumulates all of the information I've collected so far, all of the analysis I've done so far. So let's say I want to copy this pie chart. I'm going to click on this pie chart, just simply say copy, Control C or whatever, say copy. I'm going to open a Word document. Okay, this one, oh, actually I have this one open. I'll put it right into here, copy and paste here. How's that, right? And I'm going to say edit, paste. Now there's 2 ways I could just simply say paste, works fine. There it is. It's pasted into the Word document, right? I can click on it, resize it, and so on and so forth, move it around the document if I want to, you name it, right? I could have also said, I'm going to go up here, Edit, Paste Special. When I say Paste Special, it gives me the opportunity to paste it in different formats. In this case, it doesn't make much sense because I'm just going to paste it as a picture. But in the case of a table, I could paste it in as formatted text, unformatted text. I could paste the table in as a picture, and so on and so forth. It's on Blackboard under Lab Session2, and it's a Word. It's the only Word document that's over there. Okay, it's called in-class SPSS, blah, 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 so on and so forth, exercise. Okay, so I'm going to take a look at the next one. Produce a bar chart for the variable summarizing the data for, let's see, bar chart, we did that. Descriptive statistics, let's take a look at that. Use it to calculate the descriptive statistics for the age of the mother. Anybody remember what the variable was there? MH, right, was the variable there. So I'm going to go back to SPSS. I'm going to go to the data window, okay, and I'm going to say, where should I start? I want to do an analysis. Analyze. Descriptive statistics. This time, I'm not going to go into frequencies because frequencies only counts things, right? I'm going to go into descriptives. Okay, I'm going to go into descriptives. I want to know some descriptives about the age of the mother. Okay, so let's see. Race of the mother, marital status, age of the mother. Here we go right here. I'm going to move that into variables. And now I'm going to click on options. And in options, it lets me choose what statistics I want to calculate. It already has mean calculated, standard deviation, minimum, maximum. I'm going to click range. I'm going to click variance. Why not? Okay. And I'm going to click continue. And I'm going to click OK. Our output window is going to open again. It's going to add it to the end of our output window. And the average age of 800 mothers, the average age of the mothers is 26.92 years. The standard deviation is 6.107. The variance is 37.299. What's the relationship between variance and standard deviation again? Square root, right? Square root of 37.299 is 6.107. Right? And we got the mean, we got the range, the minimum, the maximum, the range, and so on and so forth. We have a lot of interesting statistics about this sample, and we got it almost instantaneously for 800 people. Okay, I'm going to go back, do that one more time. I'm going to say analyze descriptive statistics, except this time I'm going to bypass descriptives and go to this thing called explore and do exactly the same thing. Now, it gives me a whole bunch of other boxes. I'm not going to use them at the moment. I'm just going to take the mother's age again. Mother's age, where did it go? Yeah, age of mother, there it is. Okay, move it into what's called the dependence list, just the first box, let it know that that's what I want to work with. I'm going to click on statistics. And let's see, descriptive statistics, it doesn't give me a lot of options here because it's just going to calculate most of them for me. Don't worry about that confidence interval right now. It'll come up later on. I'm going to click continue. I'm going to go into plots since I'm here anyway. And I'm going to say, it's going to do this thing called a stem and leaf plot. Don't worry about that right now. Oh, hey, I know what a histogram is. Let's click that off. Let's get a histogram. Okay, I'm going to say continue. And then I'm going to bypass options for now. I'm just going to click OK. Okay, I clicked into statistics, made sure descriptives was checked off, so it's going to do the descriptive statistics. Then I went into plots and made sure that histogram was checked off, among these others. Okay, plots and histogram is checked off, and then I'm going to click OK. Okay, and here we go. This time we got a lot more statistics, didn't we? We got our variance, standard deviation, range, interquartile range, a whole bunch of other statistics as well. Notice the numbers are the same, though. Still 26.92 years. The standard deviation is still 6.107, but we got a bit more information. Not only that, we got a pretty detailed histogram that are produced for us as well, which we can copy and paste into another document, just like before. And any of these tables, this table right here, I can click on this table, say copy, go into my Word document, and paste it. Paste, and notice I can format, unformatted, formatted text, so on and so forth. you may find my program, my SPSS has a bug in it. It won't let me paste it as a picture. Your version will let you paste it as text or even a picture. Sometimes it's handy to paste a big table in as a picture because it makes it easier to resize it and move it around. But I'm going to paste it in as a formatted text. There's a table, paste it into a Word document that you can use in a report or a paper, another course if you're analyzing data for another course, and so on. Okay, so I'm gonna move on, and again, you guys will be able to go back. This is a stem and leaf plot. It's just basically another way of doing that same histogram. And what's this? Box plot, right? Remember what we call these feathers. These light lines at the end are called feathers. Okay, what's the bottom feather represent? The small, well, it represents the lowest value, right? And the upper feather represents the highest value. The highest value happens to be, I don't know, oldest mother was about, I guess about 43 or something like that. Now, if any of those values are more than 1.5 quartiles from the median, they'll appear as stars instead of outside of the feather, right? Those are considered by SPSS using that rule, outliers. That doesn't mean you have to treat them as outliers. You have to make a judgment about that. Okay, but that's the way, so if you see stars, that's what it really means is you had a few values that SPSS is saying to you, well, it's so far from the median that maybe you should consider possibly these things are outliers. Okay, does the median look like it's right in the middle of this thing? No, it doesn't, does it? Right? So it looks like there's women that are much older than the median, more than there are women that are much younger. So what does that tell you? It tells you that this sounds like it's skewed to the right, right? There's some women that are older than you would expect. Let's take a look at the histogram. And indeed here, the histogram looks like this. These values look like they're, looks like this would be our distribution, but it looks like it's pulled over by these women that are a little bit older than the rest of the group. Right now you get, if they did this now, right? I don't know where the data came from. I think it's like a decade or two old. But now you might get some women in the 50s now, right? Things have changed a little bit, right? So you really might get a distribution that's skewed to the older, And why do we say skewed to the right or positively skewed? Because people that are further out on the right side are moving the mean to the right. The median stays in the middle. Right? Because it's not affected by one or two people that are much higher. But the mean is affected by people that are much higher. For instance, we've got 25 people in this room right now, right? You guys leave here, you get new jobs as public health professionals, and some of you making 50 grand, some 60, some 40, some 90, so on and so forth. One of you signs a contract with the next year, you're making $5 million, right? If I looked at, now the middle value is still going to be 60,000 or whatever the middle person is, but the average is going to be $200,000, right? So that person is skewing the mean, pulling the mean up positively away from the median. That's why we say skewed positively or skewed to the right. This is skewed to the right or skewed positively. Okay, and if there was somebody that was, doing pro bono work making nothing, they would skew the mean to the left or negatively. Okay, so let's move on from that. That's how we would get that. Again, copy and paste it in. Let's see what else we can do with this.
One question.
Yes. Only one question?
Only one.
Okay.
So for the descriptives, so the age of the mother, that table that you copied, that would technically suffice the answer for that question.
Yes.
Right? Okay.
Yes. Histogram, so on and so. I think that's pretty much. I think this is a good place to stop because it's like 8:50 now, and that's when we're legally required to stop, or you could file a protest with the bursar or the registrar or somebody like that if I continue. I have to tell you, I sometimes teach this 4-hour environmental lab across the hall over there. And one semester they have another, that's for MS majors. They have another version for MPH majors, which is apparently 2 hours. Nobody bothered to tell me. Right, so I was going through this thing for about I was in about 2 3/4 hours before the students were so polite. She said, "Professor DeVito, are we going to be done soon?" So what are you talking about? We got another hour and a quarter to go. She says, "Oh no, this is only a 2-hour class." So they literally sat there for 45 minutes after the period was over before they told me I was going on too long. So 8:48. Good night, guys. Okay, so this will be online, so you can redo this. And you want to know something? I'm seeing that we're struggling a little bit. So I'm going to make sure that over the next couple of weeks, we get a little bit more help on the Excel. Okay, now tune into this other session on Excel. Okay, as well, because you'll see a PC version of it. You'll see another perspective on how to do it. But like I said, you'll be able to see this again online.
So you're gonna
And
repeat again stuff from the class.
yeah, and well, you'll see. No, I'm recording this, so you literally see what we just did tonight again. Yes, we have a homework due for next week. If you guys still seem to be struggling, we can push it a little bit. It's on there. If you look under the assignments tab, it's been there already. And didn't I tell you guys to get city program done ahead of time so you wouldn't have to worry about it now? Right? Don't you wish you did it now? Oh, okay. Some of you did do it. Yes. I'm sorry. Go ahead.
I just wanted to know for the.
Oh, let me say good night to the guys online. Good night, guys. And like I said, this will be online. I'll post the link and so on and so forth. Good night.
For the SPSS download,